Right, so if there really was a demo, it probably showed you some code a bit like this. Iterators are objects which allow you to iterate through each element of a collection, and that gives you very flexible ways of handling collections. So in this section of code, we first of all declare an iterator over strings called nameIter, and then we say, well, what is this name iterator actually going to iterate over? It's going to iterate over the names collection. So we ask the names collection to provide us with an iterator, and we allocate that iterator to the variable we just declared, nameIter. And then we can use it as an iterator. You can think of it almost as a kind of flexible pointer that goes through the collection. So we can say while nameIter has next, so for as long as there are some more elements in the collection, so it's possible for the name iterator to find a next element. We ask the name iterator to get the next element, and we assign it to the local variable of type string called element. And we can do some stuff with element if we wish. And another thing we can do is we can ask the name iterator to remove the current element, and so on. And there's lots more that you can do with iterators. You can look that up, but that's just the scratching the surface that we're going to do here. So that's all we want to say about array lists, and we've just seen how to iterate over an array list. The next collection example that we're going to look at is a map, also known as associative array. The terminologies mean pretty much the same thing. So an associative array associates a collection of unique keys with values. It's a dictionary, if you like. So you can think of it as being a generalization of an ordinary array. An ordinary array allows you to use an integer as a key, and to use that integer key to look up the value at that particular integer. But in an associative array, you can use a key of any type, and strings are one of the most useful things. So for example, you can use a person's name as a string, and you can look up their telephone number as the value. Or you can get an internet domain as a string key, and you can look up its IP address, and so on and so forth. And so this relationship between the key and the value is often called a mapping, and in Java the main collection class that implements associative arrays is hashmap. So let's think a bit more about what you can and can't do with a hash map, and in general with an associative array. So you can map people, perhaps these are strings or perhaps these are person objects, doesn't really matter, to their metric numbers stored as values. So Peter's metric number is S, whatever that says. There's nothing stopping you having different keys pointing at the same value, and that will happen, for example, if we map words to their length. We see that we've got this and time, both of which are strings of length 4, and so the value associated with key this is 4, and the value associated with key time is also 4. Nothing wrong with that. What we can't do is to have the same key more than once, because an associative array is supposed to allow you to look up a value based on a key, and in this case we wouldn't know which of those two metric numbers to return if we were tried to look up the key Peter, so that won't work. Keys must be unique within the collection.
Here's what I found.
However, it is perfectly possible to allow the type of value to be array or some other object, so you can end up saying, well, if you really want to associate Peter with more than one metric number, then perhaps the type of your values should not be metric number but should be list of metric number or something like that. Okay. How do you use it? Very much the same as you are becoming used to. You import its class, in this case Java util hashmap. Just as with the array list, you don't need to give the type you're planning to use it at. You declare it and initialize it, And here you do have to give two type parameters. You have to give the type of the key and the type of the value. In this case we're going to say we're going to use a string as key and an integer as value. One thing to know, you may come across people talking about hash table and wonder what the difference is between hash table and hash map. They have some subtle differences, in particular to do with how they handle concurrency. For most purposes, hash map is the one you want to use, and hash map is the one that we're mostly going to talk about in this class. But there are many, many different collection classes, and you probably should have a look around the JDK documentation and explore what there is. Let's look at a bit of an example here. So, given a string of words, we're going to derive an associative array that maps each word to its length. So there are going to be several steps involved in this task. First of all, we're going to split the string on white space. So we start with a long string like this one at the bottom. This is the time and this is the record of the time. So we send that string the split method with some white space as an argument, and the result of that is that we get out of that an array called words of string. Then we're going to iterate over that array, and for each word in the array we're going to add it as a key, and we're going to associate it with a value which is going to be its length. We know how to find the length of a string, you just have to send the string the length message, so we're going to do that. Now in this case, when we come across the same key again, so we've got, for example, two different instances of the word this in this long string, we're not going to do anything special, we're just going to overwrite the previous association. In this case, although that wastes a bit of time, it's completely harmless because the length of the word is the same in each case. It doesn't matter. The length of this doesn't change between one instance of this and the next instance of this. So it's going to look like this. We're going to use the put method of hashmap. That's the one we need to do, and we provide the put method with two arguments, which are, as you would expect, the key and the value. So I don't think there's any more to say about this. Note the use of the enhanced for list for loop, which is often a useful thing to do. In this case we're iterating over an array words, remember. Get with taking a key as argument is pretty obviously the way to get the value. So for example, if we wanted to say look up the length of the word record, we could use wordLength.get with the argument record, and the result would be 6, which we could then assign to an integer. The method keySet is a thing you can send to a hash map, and it will get you back the set of keys in word lengths. Strictly speaking, the array, I think you'll find. You should look that up if in doubt. And we can loop over that exactly as you would expect. Isn't it interesting that you don't actually need to know what the type of the return value of keySet is in this code fragment? It might be an array, it might be an array list. You can't tell from that fragment because the fragment would be exactly the same either way. But this does what you would expect. If we iterate over all the keys in the hash map and then print out using that format string there the key and then the arrow and then the value associated with that key, we indeed get a list of all the distinct words that appear in that string we started with, each with their lengths. The order in which they appear is probably best thought of as arbitrary in this case. We can send the overloaded println message, the argument which is a hash map in this case, and as per usual it will do something sensible thanks to the wonders of the Java JDK, and in this case something sensible is to print it out in that format using curly brackets, key 1 equals value 1 and so on. You can of course also put your own data types into a hash map. You're starting to see how this goes now, I hope. So we can, for example, have a hash map of size descriptions and circle objects, and that works just as you would expect. You do have to be a little bit careful if you want to start using your own data types as keys, as opposed to what we've done in this case, which is to use our own data type as values. you can look up the details, but roughly speaking you will have to make sure that they have an equals method and they have sensible behaviour when you try to hash them, in order to make sure that the algorithms for looking things up in hash maps actually work correctly. You can also write nested hash maps, just as we saw you could write nested array lists, and again type inference saves the day, and we don't have to repeat that long complicated type that you see on the left of that first line. Also on the right of the first line, Java will do the magic. What else is there to say about this? Not a lot really. You can stop and read it carefully. So in summary, you can use ArrayList where you want your arrays to be able to grow and shrink, or you want to be able to easily insert and remove items in the middle of the array, or you want to do anything else that is provided by the API of ArrayList but not so easy in an array. You can use the hash map when you want to use keys other than a predetermined list of integers, most especially when you want to use strings as keys, but it could be other things as well. You can look up a lot more information about ArrayList and hash map and lots of other collection classes as well in the JDK, and you probably should, certainly if you want to start writing more real Java code in future. And it's useful to know how you can iterate over collections using an iterator object, and again you can look up lots more detail of that in the JDK. There's no point in spending lecture time going over every detail when you can much more efficiently read it. And that's the reading for this lecture.